Hello, welcome back to the second part of the Introduction to AutoCAD 3D tutorial. In the first part, we have created a three-dimensional object by the method of extrusion, and we have also discussed in detail the various visualization and navigation tools in AutoCAD to generate standard engineering views. In this tutorial, we will see the basics of 3D modeling. What exactly is 3D modeling? The 3D modeling is the process of generating a three-dimensional representation of an actual or an imaginary object for various applications such as fabrication, design, visualization, and presentation. In AutoCAD, we can create a 3D model in three different ways. The first method is by using the solid modeling, which you can see here. Then we have surface modeling and mesh modeling. These three modeling techniques differ in various aspects. Since it's practically impossible to demonstrate all the three modeling techniques in a single tutorial, I would like to use solid modeling to demonstrate the basics of 3D modeling in this tutorial. Solid modeling is the most commonly used modeling technique among the three modeling methods. So let's get started. First of all, I would like to create a thick cylinder on this face. You know that you can create a cylinder in AutoCAD by constructing a circle first. Then you can extrude that circle through a certain distance to make a cylinder. So I'll click on the circle command and I'll choose the center radius method, and I can take the cursor on this face. I'll just make a click to define the center. When I drag my cursor to specify the radius, now you can see that this circle will be drawn on the XY plane. So if you want to construct a circle right on this face, you have to align the XY plane here. So I'll erase this circle. And how will you align the XY plane on any desired face in AutoCAD? For that, you can go to the Visualize tab, and I'll click on the 3-point option of UCS command. When I'm asked to specify the new origin point, I'll click here, and the new x-axis direction, I'll click here, and the y-axis direction, I'll click here. Now I have the XY plane aligned on this face. Next, I can go to the circle command, take center radius option, and I can choose this center as well as, and I can specify a radius to make the circle. I'll give a radius of 30 centimeter to make the circle. Now the circle is drawn on this face. Hence, you have to always align the XY plane on any desired face whenever you want to work on those faces. This becomes often inconvenient and tedious. But in AutoCAD 2007 and higher versions, we have a new method by which you don't have to manually align the XY plane each and every time when you work on faces. That is by using the dynamic UCS. You can just press the F6 function key to activate this. You can see the dynamic UCS here, and in the lower versions of AutoCAD, you can see the dynamic UCS as a button at the status bar. If this button is not displayed, you can just click on the customization button and you can activate the dynamic UCS from here. So let's undo the previous steps which you have done. I'll just give undo. Now the UCS is taken back to the default orientation. Now I would like to construct a circle on this face. Next, I will also activate the 3D O-Snap. You can just click on the arrow button over here, and you should make sure that the center of face button is active. This will enable you to snap on to the center of any desired face. You can activate the 3D O-Snap by pressing the F4 function key. Next, I'll go to the center radius method to construct a circle. I'll bring the cursor on this face. Now you can see that that face is highlighted. Now you can just make a pick here to select the 3D center point. Since the 3D O-Snap is on, the circle is drawn. Now it will ask you for the radius. I'll give the value 30 centimeter. So even without aligning the UCS on this face, I could create a circle in a more convenient manner because the dynamic UCS was on. Next, I'll give an offset command to offset the circle through a distance of 10 centimeter. So I'll just click on the offset command. When I'm asked to give the offset distance, I'll give the value 10. When I'm asked to select the object, I'll click on the circle. I'll pick a point inside to define the side. Next, I'll extrude these two circles through a distance of 45 centimeter. So I'll click on the extrude command and I'll select these two circles. When I'm asked to give the height of extrusion, I'll give the value 45. Now you can see that both the circles got extruded. Now I would like to remove the volume taken up by the inner cylinder from the outer cylinder so that I can perform a kind of material removal. In fact, subtraction is a Boolean operation. In AutoCAD, we can perform Boolean operation between two or more objects to edit these objects in a variety of ways. So let's see this concept in detail. The union operation joins two or more solids into a single solid object so that if you click anywhere on this object, the entire object will get selected. Subtraction is a material removal operation in which the volume taken up by the second solid is subtracted or removed from the first solid. In the intersection operation, the software retains the volume which is common to the solid objects taking part in this operation. After intersection, the original solids will get deleted. The interference operation is similar to intersection, but in this process, along with the common volume, the original solids are also retained. The common volume can be separated using the move command. The software divides the solid objects taking part in this operation into two sets of solids. After selecting the first set, we can give an enter, then you can go for the second set. Let's come back to our model. Now you know what is meant by subtraction. I'll click on the subtract command. It is available in the solid editing panel. And I'll select the first set of solid. I'll give an enter. And I'll select the second set of solids. And I'll give another enter. Now when you go to shaded representation, you can see that the inside volume is removed from the outer volume. Next, we will perform a filleting operation on this outer edge. For that, we have to go to fillet command. In AutoCAD, the fillet command can not only be performed between two edges, but it can also be performed on an edge of a 3D solid. Well, let's do that. I'll select the fillet command. Okay, it's available in the modify panel, and I'll specify the radius. I'll click on the radius. I'll give a radius of 5 centimeter. When I'm asked to select the edge to fillet, I'll select this particular edge. Then it'll ask you for the radius for reconfirmation. I want to fillet with the same radius, so just give an enter. Then give one more enter. Now you can see the filleting at the edges. When you click on the solid, you can see that it's a separate object and this rectangular box is another object. Now I would like to convert these two objects into a single object using the union command. So I'll click on the union command and I'll select this particular object as well as the cylinder and just give an enter. Now this is a single object. Next, I would like to perform one more fillet on this particular edge, which meets with the flat face of the rectangular box. So I'll go to fillet again and I'll specify the radius. Okay, the same radius I would like to use, so I don't have to give it again. I'll just give an enter and I'll select this particular edge, then just give another enter. Then if you want, you can select more than one edges. I don't want to select any more edges. Give one more enter. Now you can see that it has performed fillet on this edge as well. Next, we will work on this face. If you want to create a profile on this face, as we have seen before, we can either align the UCS manually on this face using the various options of the UCS command, or else we can activate the dynamic UCS. Then we can straight away go and highlight this face and make this face as the construction plane. Then we can create profiles. But this time, I would like to disable the dynamic UCS. Then I'll create a profile after aligning the UCS manually on this face. So let's go to Visualize tab and I'll select the face option of the UCS command. You can access the same option by giving the UCS command using the keyboard, and you can type the letter F for face. Then I'll take the cursor onto this face and you can see that this face is highlighted, and I'll make a click. Just give an enter to accept this orientation. Now the UCS is aligned on this face. Before we create profiles, I would like to change the color. So I'll type Ctrl 1 and I'll select the properties panel. I'll select a color and I'll use this particular green color as the current color. Then I'll click on the rectangle command in the draw panel and I'll take my first corner here and the opposite corner here. Give an offset command and I'll give an offset distance of 5 centimeter. When I'm asked to select the object to offset, I'll select this particular profile which I've drawn just now and I'll select the polyline. When I'm asked to select the side, I'll click on the inner side. Now just give an enter to go out of this command. Now I would like to erase the outer profile, so I'll click on the erase command and I'll select the outer rectangle which I've created since it's no longer required, and I'll select the polyline. Just give an enter. Next, I'll extrude this profile. So I'll click on extrude command. When I'm asked to select the profile, I'll select this rectangle. I'll give an enter for confirmation. Then I'll go to the taper option of extrude command. Okay. When I'm asked to give a taper angle, I'll give 30 degree as the taper angle. Next, it'll ask you for the height of extrusion. I'll give 30 centimeter as the height of extrusion. So this is what you call as tapered extrusion. In tapered extrusion, the extruded surface makes a taper angle with a vertical. Next, we will extrude this face of the solid object using solid editing. In AutoCAD, a solid model can be edited using the solid editing command or by using the number of options available in the solid editing panel. Using this command, we can edit a solid object based on subobject levels. Let's see this illustration to get a complete picture of the various subobjects within a solid model. We can access and alter these subobjects in a variety of ways using the various options of the solid edit command. When we consider the tapered rectangular block, we can see that it is made up of 6 different faces. So, face can be treated as a subobject. When you analyze a face, we can see that each face is made up of 4 edges. So, edge can be treated as the second subobject within a solid model. Several such faces makes a solid body. And several such bodies makes an entire solid object. We can access and edit any of these subobjects to get desired results. So we have a lot of flexibility in editing a solid model. Let's come back to our 3D model and explore various solid editing operations in the solid editing panel. If you want to perform the solid editing based on the edge level, you have a number of options over here. You can click on these options. And if you want to perform these operations based on the face level, you can click on this pop-up list and you will get a number of options here. You can extrude a face, you can taper a face, move face, etc. And if you want to perform these solid editing tasks based on the body level, you can click on this pop-up list and you will get a number of options. I'll demonstrate the procedure to extrude a particular face of a solid. Okay, so I'll click on the extrude face option and I'll select this particular face to be extruded. And that face is selected. I'll just right click to give an enter. When I'm asked to give the height of extrusion, I'll give the value 30 centimeters. Now it'll ask you for a taper angle. The default taper angle is displayed as 30 degrees because that is the most recent taper angle which is given. Now I don't want to taper this particular face. So I'll give the taper angle as 0. So I'll give an enter and one more enter to go out of this command. Next we will create a rectangle on this face. So I'll click on the rectangle command and I'll click the first corner over here and the opposite corner here. And I'll go to offset command and I'll offset this rectangle through a distance of 5 centimeter. I'll type the value 5. Now it'll ask you to select object to offset. Okay, then this is the side. I'll pick an inside point. Next we will see the procedure to imprint a particular profile on an existing solid. When you imprint a profile on an existing solid, it will become a part of that solid. For example, this particular profile which you have drawn just now as well as this solid are two separate objects. So I'll click on the edge level and I'll select imprint. Now it will ask you to select the 3D solid. This is a 3D solid. Then it will ask you to select the profile to imprint. And this is the profile to be imprinted, that particular polyline. Now it will ask you whether you want to delete the source object. Yes, I'll give yes because I don't want the profile to be retained. I'll just give one more enter. Now when you select the solid, you can see that this profile is a part of the solid. I'm going to extrude this inside face using the extrude face option. So I'll click on extrude face option and I'll select the inside face. So I could select only this particular face. Okay, right click to give an enter. Now it will ask you for the height of extrusion. I'll give a minus 20 centimeters. Now it will ask you for a taper angle. I'll give a taper angle of 15 degrees. So I'll give an enter. So by imprinting a profile, I could subdivide a face into a number of faces. So let's orbit and see what you've done. It's an interesting result, isn't it? Next we will create this handle on the top face of this rectangular box. In fact, we will try 3 different methods to create the handle so that we can learn 3 different types of solid modeling operations in AutoCAD. First, we will try with the path extrusion, which is a third type of extrusion that is available in AutoCAD. Then we will create the same handle object using the sweep command. After that, we will make the same object using the lop command. First of all, we will create the handle-like object using the path extrusion. So we have already discussed a straight extrusion and tapered extrusion. In the path extrusion, a profile is extruded along a path. For example, when I extrude the circle along this path, I'll get that particular handle object. So let's make the path using a polyline. But before I construct a polyline, I should align the UCS on the plane of the path. So I'll click on Visualize tab and I'll go to 3-point option of UCS command and I'll keep my origin here, X direction over here and the Y direction a point which is straight up. So I'll just click a point over here. Now my XY plane is aligned. Next I'll change my color to yellow. So I'll just click on Ctrl 1 to get the properties dialog box and I'll set this yellow color as the current color. Then I'll go to Polyline command and I'll choose this midpoint as the base point and I'll give a height of 60 centimeters and horizontally I'll move 150 units in the X direction and I should come straight down another 60. Then I'll offset this polyline through a distance of 15 centimeter. So I'll go to Offset command and I'll give a offset distance of 15 centimeter. I'll select this object and this is a side. I'll pick an inside point. Now I'll erase this outer profile. Okay, that's not required anymore. Next I'll go to Fillet command. Then I'll give a radius of 15 centimeter. Then when I'm asked to select the polyline to be filleted, I'll go to Polyline option of Fillet command. So I'll click on Polyline and I'll select this polyline to be filleted. Now I have created a path. Next I have to draw a profile which is to be extruded along a path. The profile should be drawn at the starting vertex of the path and this is the starting vertex. Then you should draw a circle on the top face of this rectangular box. But before I construct the circle, I must align the XY plane on the top face of the rectangular box. For that, I'll use a different option in the Visualize tab related with UCS. So I'll click on Visualize and I'll select the top, okay, from this pop-up list. So using various options over here, you can align the UCS on various faces of a 3D object. So I'll click on top, okay. Now the XY plane is aligned with the top face of this object. So next I'll go to Circle command and I'll select Center Radius method and I'll choose this particular endpoint as a center and I'll give a radius of 7.5 centimeters. Okay, now I have drawn a circle. Next I'll extrude the circle along this path. For that I'll go to Extrude command and I'll select the circle as the object to be extruded. I'll give an enter. Now I can go to the path option. So I'll click on the path. Now it will ask you to select the path along which it is to be extruded. And I'll select this path. Now the circle is extruded along the path and we have created the handle object. Next we will create the same handle object using the sweep command. So I'll undo this operation which we have done and I'll erase this profile. Okay, the circle is erased. The sweep is also similar to the path extrusion. But here you don't have to draw the profile at the starting vertex of the path. And you don't have to align the profile on the top plane. It can be in any orientation. Okay, so I'll create the circle at a different location. Okay, I'll click the center here and I'll specify the radius of 7.5 and I'll draw the circle here. Now I'll go to Sweep and I'll select the profile to be swept. Just give an enter. It'll ask you to select the path. Okay, when you're asked to select the path, you can just click it. It's more easier than path extrusion, but it will give you exactly the same result. Next, we will create the same handle using the Loft command. Loft is a solid modeling command in AutoCAD with a number of unique features. So I'll undo the sweep which I have done. In Loft command, you can create a surface connecting two or more profiles in 3D space. Either you can perform a straight connection or you can create a surface along a path. So let's try this. I'll move the circle to create the first profile. So I'll click on the Move command and I'll select the same circle. Then I'll choose this endpoint as the second point. So this is the first profile. Now I'll give Copy command and I'll select the same profile and I'll choose this as a base point and this as a second point. In fact, this circle is a third profile. We'll have a second profile at the middle, which is an ellipse. I would like to create the ellipse after aligning the UCS with the left face. So I'll click on the Visualize tab and I'll click on the left. Now the XY plane is parallel to the left face. Next, I'll go to Ellipse command and I'll choose the center method. To create the ellipse, I'll click to define the center point and the other axis endpoint I'll define at a distance of 30 centimeter. I'll give the value 30 and the next axis I'll define at a distance of 7.5 centimeter. Okay, this is my ellipse. Now I'll click on Move command and I'll select this center point as the base point and this mid as a second point. Now it is taken to this particular point. Next, we will create a surface connecting these three profiles using the Loft command. So I'll click on Loft. You will be asked to select the cross sections. This is the first cross section, the circle, And this is a second cross section, this ellipse, and this is a third cross section. Okay, you have to choose in the right order. Now we have got a loft object, but I want the surface to be created along this path. So I'll just give an enter, and we have a path option over here, and just click to define this path. Now this is the object you have got. It's a very interesting shape, isn't it? So this is how the loft command works in AutoCAD 3D modeling. Before I conclude this tutorial, I would like to show you another solid modeling command which has got a variety of applications in AutoCAD 3D modeling. The command is called revolve. In this command, we can revolve a profile about an axis through a user-defined angle to create a 3D solid object in space. In the demonstration, the profile, which is created using a polyline, when revolved about an axis through an angle of 360 degree, can give you an interesting object in space. Let's go back to our 3D model and we will try out this command. I'll just change my view to southeast isometric by clicking on the view controls, and I'll select southeast isometric. Next, I'll restore the world coordinate setup or WCS, which is the default coordinate setup in AutoCAD. For that, I'll go to Visualize tab and I'll click on this pop-up menu and I'll select World. Now it is taken to the world coordinate setup. Next, I'll simply shift this origin point to the center of this face, because we are going to actually create the revolved solid on this face. So using the origin option in the coordinate panel, you can easily change the origin point of the existing coordinate setup. So I'll just click on origin. I want to keep the origin right at the center of this face. If you want to bring the origin right onto the center of this face, you can do that by activating the 3D snap. If it is not active, then you just simply take the cursor onto this face. It will automatically catch onto the center and just give a click there. Next, I'll change my color to a different color. So I'll press Ctrl 1 to go to Properties panel and I'll change the color to cyan color. Next, I'll give polyline command and I'll start from the origin point. So I'll click to select the origin. I'll create a horizontal line with a length of 60 centimeter. So I'll type the value 60. Then I'll move in the vertical direction and type the value 5. And I'll just give an enter to go out of the polyline command. Then I'll right click the mouse to repeat the polyline command. And I'll again start from the same origin point and I'll move through a distance of 30 centimeter. Okay, in the vertical direction. Then in the horizontal direction, 15 centimeter. Then straight down 5 centimeter. Again 15 centimeter in the horizontal direction. Then I'll switch over to the arc option. But before creating an arc, you should turn off the ortho mode. I'll just click over here, or you can press the F8 key to turn off the ortho mode. Then I'll right click the mouse and I'll select arc option. Next, I'll right click again and I'll select second point option to define the second point of my arc. I'll just click over here. Then next endpoint I'll pick here. So for that you have to activate the snap. Okay, if it is not active, and I'll click here. So I've got that endpoint. Then just right click to give an enter to exit this command. In fact, we have two segments here and you have to convert this into a single profile before you revolve it. So I have to join these profiles. So I'll go to modify and I'll select join command and I'll select this as well as this profiles to be joined as a single unit. Now you can see that it's a single profile. Next, I'll go to the revolve command to revolve that profile. So I'll click on revolve and I'll select the profile. Then just give an enter. Now it will ask you to define the axis. You can define the axis using a variety of options, out of which I'm going to make use of the x-axis option. Okay, so click on X. So when you click on X, the existing x-axis will be taken as the axis of revolution. Now it will ask you for the angle. The default angle is 360, so I'll just give an enter to accept that angle. Hence you can create a revolved solid. Now we have completed this tutorial. In this tutorial, we have seen most of the commonly used solid modeling commands in AutoCAD. Next, you should learn to apply these commands in a variety of ways to create simple and complex 3D models related with your area of interest.